Lesson 1-2 Some properties of functions, even functions and odd functions. Let's start with definition. First, the even function. The function f from x to y. X is the domain, y is the codomain. Is said to be even if f of negative x equals f of x for all elements negative x and x belongs to x. X is the domain. And also the even function, we can determine it from its curve, such that the curve of the even function is symmetric about y-axis. The odd function, what is its definition? The function f from x to y is said to be odd if f of negative x equals negative f of x for all negative x and x belongs to x. And don't forget, x here is the domain. The curve of the odd function is symmetric about the origin point. So the curve of the even function is symmetric about y-axis, and the curve of the odd function is symmetric about the origin point. Let us solve some problems about the even and the odd functions. Example 1. Show the type for each of the following functions: even, odd, or otherwise. We'll start with f of x equals x squared. Since f of x equals x squared, and here f of x equals x squared is a polynomial, so the domain of the function f is R, such that R is the real numbers, the set of real numbers. So for every x, for every negative x and x belongs to R, R is the domain, we have f of negative x equals negative x square, which equal x square, but x square equals f of x. So with respect to f of x equals x square, we have f of negative x equals f of x. So we can say f of negative x equals f of x. It means f is an even function, and we can discover it or determine it from the graph of the function f of x equals x squared. So how we can draw the graph of this function? First, we draw the two axes. -1, -2, and so on. We'll start with f of -1. F of -1 equals -1 square, which equal 1. f of 0 equals 0. f of -2 equals 4. f of 2 equals 4, and so on. Of course, f of -3 equals 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 here. f of 3 equals 9, and we can draw the curve of this function. So we have the curve of the function is symmetric about y-axis, and we have to notice for every point negative x and x, negative x and the f of x, we have its image by reflection on y-axis x and the f of x. For example, we have here negative 2 and 4. Its image is must be exist 2 and 4. And we have another point here. For every point actually, negative 1 and 1, we have its image 1 and 1. Its image by reflection on y-axis. Okay, so we can say that the function f of x equals x squared is an even function. With respect to the function f of x equals x power 3, f of x equals x power 3. So the domain equals r, because f of x is polynomial. So for every negative x and x belongs to r, what we have f of negative x equals negative x power 3, which equal negative x power 3, as negative power 3 equals negative. And we can rewrite this term in the form negative f of x as x power 3 equals f of x. So in this step we got f of negative x equals negative f of x. According to the definition, we can deduce that f is an odd function, and we can deduce it from its graph. It must be symmetric about the origin point. For that, we draw two axes equals x power 3. We start from negative 2. f of negative 2 equals negative 8, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 8. So this point, negative 2 and negative 8, belongs to the curve negative 1. f of negative 1 equals negative 1. So the point negative 1 and the negative 1 belongs to the curve. f of 0 equals 0, f of 1 equals 1 power 3, which equal 1, f of 2 equals 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we draw the curve of the function. Of course, the domain here is R, and the codomain is R also. So for every point like this, negative 1 and the negative 1 will have its image 1 and 1, And notice that negative 1 and 1 is the image of the point 1 and 1 by reflection on the origin point 0. And also the distance between the point 2 and 8 equals the distance between negative 2 and negative 8, like this, passing through the origin point. Okay, so we can say, since the curve of the function is symmetric about the origin, so the function is an odd function. What about f of x equals root x plus 3? We have the function f of x equals root x plus 3. First, we must determine the domain.